Okay, so welcome to the 8th session on grammar development with LFG and XLE. The last time, if you remember, we learned how to integrate a finite state morphological analyzer. I taught you how to write sublexical rules and sublexical entries, and we looked at the unknown entry. And I briefly introduced you to the XLE lexicon lookup model. This time we're going to change gears a little bit and look at verbal complements, comp and ex-comp. These are very, very basic, very, very classic parts of LFG. Comp is used for finite complements. Non-finite complements are encoded as ex-comp within LFG, so we'll look at both of these. Finite complements are things like things that are introduced with that clauses, that he came, that I saw. Non-finite complements tend to be with non-finite verbs. Non-finite complements tend to be introduced by control verbs. We'll talk about what those are. And I'll briefly give you some pointers to the theory of control and complementation as it has been developed within LFG. As usual, I can't convey all of the theory to you. There's too little time. I'll just show you what we need to implement grammar fragments. And another big point in this session will be, as I've been trying to do in the last few sessions, to talk to you about regression testing, making sure that your test suites, that you're using your test suites, that you're checking that your grammar is expanding rather than just changing, and some debugging tips and tricks. So let's dive into the meat of things here. So far, we've been working with the following grammatical functions, also abbreviated as GFs in LFG. So we've been working with subject, object, object2, the secondary object, and obl. But there are also grammatical functions corresponding to clausal arguments. I've already mentioned these, ex-comp and comp. And as I already said, comp is generally used for finite that clauses. Comp is generally used for finite that clauses, and ex-comp is used for non-finite embedded clauses. That's just a rough generalization. It's good enough for us right now. You can read up on grammatical functions in LFG and how to test for them in the Dalrymple book, Chapter 2, the Lexical Functional Grammar book. So I'll leave that for you to do as homework. And here I'll just give you some very, very basics. Complements, as I said, stand for finite clausal arguments. Some verbs require these. Some examples. I've given you some examples there on the slides. Think, Kim thinks that the gorilla ate the bananas. Say, Kim said that the gorilla ate the bananas. Believe, Kim believes that the gorilla eats cakes. Okay, so in each case, the part enclosed in the angle brackets, that the gorilla ate the bananas or that the gorilla eats cake, is a finite clausal argument, and in LFG this is analyzed as a comp. At C structure, these are generally analyzed as CPs, so complementizer phrases, and there's a theory behind that as well, which I cannot go into here. One thing that is important for us to note is that they are recursive, so that you can embed one complementizer phrase under another. So you can say, Kim thinks that Sandy said, and say again is a verb that takes a complementizer phrase, that the gorilla ate the bananas. And you can do this as much as you want. Kim thinks that Sandy said that the dog believes that the gorilla ate the bananas. Ad infinitum. You can keep embedding that clauses under one another. And that's something we're going to model as part of our grammar. It's not very hard to do it, actually. Okay, here's a simplified F structure with a comp. This is how you would analyze the sentence. Let's see what the sentence should be. The main predicate is believe. It takes a subject and a comp. The subject is Kim, third person singular, case nominative. The other argument is the comp. The comp is a whole predicate with a subject and an object again. So it contains a pred, eat, which has a subject and an object. The subject is Kim. Actually, that should probably be gorilla, not Kim. That's a typo there. So Kim believes that, not Kim, but the gorilla ate cake. Okay, that's what this is standing for. Object is cake. Okay, so that's the comp business. Okay, so we have a main predicate and it subcategorizes as we've always seen for arguments, except that now we've also included a clausal argument. All right. So now let's move on to non-finite clausal arguments. These are called excomps in LFG. And again, they're lexically selected for by certain verbs. These verbs tend to be called control verbs. And some very famous examples are persuade, promise, and want. So the examples here are Kim persuaded the gorilla to eat cake. Okay, so persuaded, the verb. It takes a subject, Kim, an object, gorilla, and it also takes an excomp, which is to eat cake. Okay, and I'll talk about the structure of the excomp a little bit. Promise, Kim promised the gorilla to eat cake. Want, Kim wanted to eat cake. And another version of want where Kim wanted the gorilla to eat cake. Okay, so in each case, the thing that is in the angle brackets is the excomp. Excomp at F structure, and they're generally treated as a VP at C structure. Note that just like the comps, they're recursive as well. So we can have Kim wanted to persuade Sandy to eat cake. We have two verbs in here, wanted to do something. What did Kim want to do? She wanted to persuade Sandy to eat cake. Kim wanted to persuade Sandy to promise the gorilla to eat cake. 3 of them in there, etc. They can also interact with the comps, so you can, both of them are recursive, have recursive structures, and they can interact with each other. So you can get things like Kim thinks that Sandy wants to persuade Peter to believe that the gorilla ate cake. So what do we have here? We have thinks, takes a comp, that Sandy, and Sandy wants to do something more complex. She wants, and embeds an X comp here, to persuade Peter to do something. To do what? To believe. So this is all the X comp, and then we have a comp that the gorilla ate cake. Okay, so we have a comp, embedding an X comp, embedding another X comp, embedding a comp. And we can do more and more of that. Kim promised Sandy to believe that Peter persuaded the gorilla to eat cake. So here we have promised Sandy to believe. To believe is an X comp, embedding a comp that Peter persuaded the gorilla to eat cake. To eat cake is again an X comp. We'll see how this works in the implementation some more. Okay, what's an important point? These things can interact, and they have a recursive structure, so we need to be able to model that. Right, the other thing to know about excomp is the notion of functional control. The non-finite clauses are called excomps. There's this X in front here, because the embedded clause contains an open subject argument that is controlled, that is taken to be controlled by an argument in the matrix clause. And the way to look at it is this. If you're looking at something like Kim persuaded Sandy to eat cake, you have to ask yourself, who's doing the eating? And the answer is Sandy. So in this case, the object, Sandy, of the matrix verb persuade is controlling the excomp. If you look at Kim promised Sandy to eat cake, who's doing the eating? Well, in this case, it's not Sandy, it's Kim. So in this case, the subject of the matrix verb is controlling the subject of the excomp. Okay, Kim is the one who's eating cake. Over here, Sandy is the one who's eating cake. So here, Sandy is the subject of the embedded excomp. Here, Kim is the subject of the embedded excomp. And this is lexically determined. This was a big point back in the 80s. It's lexically determined because persuade is the type of verb that wants an object. Promise, an object control structure. Promise is the kind of verb that wants a subject control structure. Right? So it's a lexical property of the verbs, and we'll have to encode this property in the lexicon, and I'll show you how to do that. Okay, so as I said, excomp is considered to be an open grammatical function because one of its arguments is not, it doesn't appear within the clause, it's empty, and it needs to be controlled from somewhere else. X-adjunct, just as a note, is its adjunct counterpart. Okay, so we have two open functions in LFG. One is excomp, one is X-adjunct. And an example for an X-adjunct is, having eaten the cake, Kim ordered some tea. Same thing again. Who's eating the cake? Well, Kim. But in this case, this is not an argument of order. This is an adjunct. It's modifying. Kim ordered some tea while after having eaten the cake. Okay, so this is modifying this sentence here. So it's a sentential adjunct, and it's an open function because the subject here is missing and is being controlled by some entity outside of the sentence. Okay, so that's just as a note. We won't be implementing X adjuncts right now, but it should be obvious how to do it actually. So, getting back to functional control. As I said, it's a lexical property of the verb, so each control verb needs to specify in the lexicon whether it's a subject or an object control verb. And actually want is a special case, it does both. Okay, so I can say Kim wants to eat or Kim wants Sandy to eat. In the first case, Kim wants to eat. Kim is doing the eating. In the second case, Kim wants Sandy to eat something. Sandy is doing the eating. So it can do both. It's quite exceptional. But just let us look at persuade versus promise. So persuade is an object control verb. Promise is a subject control verb. Right? Here Sandy is doing the eating. Here Kim is doing the eating. So how do we encode that? First, I'll show you the analysis. This is a simplified F structure. This is what you should be aiming for in your analysis, something like this. So persuade is the main predicate. It has a subject, an object, and an ex-comp. Kim is the subject. Sandy is the object. Kim persuaded Sandy to do something. The to do something is the ex-comp. What is the to do something? Well, it's contains the predicate eat, so to eat something. To eat what? To eat the cake. So cake is the object. The subject is lexically determined to be controlled by the object of the matrix verb. This is what this big fat line is here for. This is how things are rendered in the theoretical literature on LFG. You're saying that this subject here is empty. This subject here is identified with the object of the matrix verb. Okay, this big thick line is supposed to indicate that these two entities are the same thing. The subject is the same thing. The subject of the embedded verb is the same thing as the object of the matrix verb. That's what this line is supposed to indicate. Okay, so this is an object control verb. We say that the matrix object is the same as the embedded subject. Now let's look at a subject control verb, promise. Promise also takes a subject, an object, and an ex-comp. Kim is the subject. Sandy is the object again. So Kim promised Sandy to do something. The to do something is encoded in the ex-comp. It contains a predicate eat. That's what's being done, to eat. Eat takes a subject and an object. Again, the subject is not specified within the clause. The object is to eat cake. That's the object, okay? And in this case, though, the subject is being controlled by the subject of the matrix clause. So it's Kim who's doing the eating, or is going to do the eating. Kim promised Sandy to eat the cake. Okay, so Kim is the one who's doing the eating. So it's a subject control. Right. So in our analysis, in our grammar development, we need to ensure that we get this kind of an F structure. So how do we do that? So the main work, some of the main work is done by a control equation, the lexical specification. So as part of the lexical entry for persuade, we have to add this entry, ups ex-comp subject is equal to ups object. The subject of my ex-comp is the matrix object. That's what this says. Okay? So this is an object control verb. Kim persuaded Sandy to eat cake. Ups object is Sandy, is the ex-comp's subject. In contrast, promise says the subject of my ex-comp is the matrix subject. Okay, here's the matrix subject. Kim is the subject of the ex-comp, that's this one, and is the subject here. So eating the cake. Okay, so that's what we have to put in the lexicon. We also have to write other lexical entries. We'll see how to do that in a minute. Just a quick note. The basic theoretical concepts for understanding control and complementation were worked out in the early 1980s. It's a very, very early part of LFG. The classic article, which is still very relevant today, is by Joan Bresnan, Control and Complementation. It's been reprinted in Linguistic Inquiry. That might be easier to get hold of than the collected volume. Some of the status of comp and ex-comp are being debated currently in the theoretical literature, but for our purposes, for the grammar development purposes, what we've done here, this is what we can get started with. And we're now going to, in fact, get started with actual grammar development. I'm going to do some test suites and debugging, and I'm going to show you how to expand the grammar to include ex-comps and comps. And then you will do some more as part of your exercise. Okay, so, and some of the debugging will involve the morphological analyzer. So at this point, we're going to leave the presentation and switch to the grammar. So I'm going to call up the grammar. We're working now with grammar 7.lfg. Okay, going to make that a bit bigger. And as usual, we're going to look at it a little bit. Well, actually, you should be very familiar with this grammar by now. We've got our morphological analyzer in here, etc. What we're going to do right now is we're going to say, okay, now we want to add some more to the grammar. We should make sure, actually, that the test suite is still running. So I'm going to call up the test suite, which is test suite 7. I've made a new test suite 7. And in here I've got the sentences I'm going to cover with you today, integrating comps and ex-comps, but I've commented them out so far. Below are the sentences that are supposed to be working so far. So let's just make sure that they do indeed still work. So I'm going to start the new XLE process and create my parser. Create parser grammar 7.lfg. Okay, that's loading, that's good. And now I'm going to do some regression testing. I'm going to make sure that all the sentences I had before still work. So parse test file test suite 7.lfg. And what we get here, I'll make it a little bit bigger, is we get a bunch of statistics. So let's look at them. Let's scroll back to see where it started. Here's parse test file test suite 7.lfg. And it says parsing sentences 1 to end, and it goes through each sentence. All right, so for sentence 1 it says 3 words, got 1 parse, all fine, all fine. But then on this sentence, number 5, we get a mismatch. The sentence is the dog appears and eats a bone. And what the system is telling us is that instead of 1 parse, we now have 2 parses. And the next sentence, same thing. The dog eats and sleeps. We have 2 parse instead of 1 parse. So this is something we're going to have to look at in some detail. Let's scroll down and see if there are any other problems. Everything else looks pretty good here. There's no mismatches. We do have one mismatch down here. The dog devours bones in the park. It's gone from 0 to 1. That's very good, actually, because this is a sentence, this is way back from the beginnings of the course, where park was not part of the lexicon, so this sentence never parsed. But what we did when we integrated the morphological analyzer is that we now have access to all the nouns in the lexicon of the morphological analyzer, so park can now be parsed as well. We now have access to a lexical entry for park, so this sentence parses. So that's very nice, that's good. Okay, well, let's go back to the 2 sentences that somehow got an extra one. We don't want extra parses if we can avoid them, so the dog appears and eats a bone. Let's find that in our The dog appears and eats a bone in our test suite. That's when we were doing coordination. So let's parse this one, escape control P, and see what's wrong. So we get a tree, we get two valid trees. This one looks good, appears and eats a bone. Let's look at the F structure. That looks pretty good too. I say that without having looked at it. We have a coordination, appear dog and eat dog, bone. That actually looks good too. So let's look at the other tree. That looks like a kind of analysis we want. Let's look at the other tree. And that looks pretty good too. It has a VP and eats a bone. That's all good. And the F structure is good too. So what is the difference? Why are we getting two of these? We can look at the FS chart and maybe see what's going on there. This tells us that there's two possibilities and that the two possibilities are here, pred, eat dog bone, eat dog bone. They seem to be exactly the same. So what is going on? And then remember, so I have an idea. Remember that I just talked about the morphological analyzer. We also integrated verbs. So maybe there's something going on with the verbs. So let's look at eats and see if there's any morphemes going on here. Show morphemes. And there are no morphemes here. This seems to be a full verb entry coming out of the lexicon. We can look at the previous tree and say show morphemes. And this is actually an entry coming out of the morphological analyzer. Okay, so this verb entry, this verb, we have verb stem base, verb, present tense, third singular. This is actually coming out of the morphological analyzer. The second tree, there's no morphological analysis available. It's coming from our full form lexicon. Okay, so we have two entries for eat, it seems. So let's see if we can fix that. So let's find the grammar. Okay, make it bigger again. And let's go find eat. Let's go under LFG, rules, templates, lexicon menus. And here's my lexicon. Let's find eat. Can we find that here? No. Okay, I'll just search for it then. Eat. Eats. Okay, so here's an entry for eats. This is my full verb entry. But in fact, I also have an entry up here, which is just the stem, which is pointing to the morphological analyzer. So I'm getting eats from two sources, one from over here and one from over here. So I don't actually want this source. We decided to get rid of full forms as much as we can because we have the morphological analyzer now. So we don't want to have to code all this by myself. So this is an unnecessary entry. Necessary entry. Have morphological analyzer now. Okay, so I think it's unnecessary anyway. Let's try it. We only made changes to the lexicon section, so I don't have to reload XLE. I can just try it again. Here, the dog appears and eats a bone. Escape, Control P, let's parse it. And now, in fact, I only have one tree left. That's very good. So I got rid of that analysis that I didn't want. And that still looks good. And what was the other one? The dog eats and sleeps also had two parses. Let me check that one. The dog eats and sleeps looks good as well. BP coordination. We have an eating dog over here and a sleeping dog over here, and they're coordinated. That looks good. And only one analysis. Okay, so fix that problem. But let's make sure that fixing that problem didn't cause other problems. So I'll run my parse test file command again. And I've got one mismatch. Let's go see what that is. Okay. So that's good now. The dog devours bones in the park. That's good now. This is the one we wanted. So everything else still works. That's very good. So now what I'm going to do is I would like to keep this test suite. What happens, I'll show it to you over here, is that whenever I run parse test suite, it makes a whole bunch of files. You can read about this in the documentation as well. It lists the errors that were found, and in particular it makes a test suite file new, which is what all the new information is in. So we can look at that. Emacs test suite.new. Let's have a look at that. Okay, so what it has here all the information. So it hasn't parsed these because these are commented out, but here it says John hates bananas, went through with one analysis, that many CPU seconds, this many subtrees were unified. So it has a record of all this. Dog was hated by John, has one analysis plus one, which was unoptimal, this many CPU seconds, 45 subtrees unified. Okay, so this has a lot of information in it. I can scroll down to the end, and it gives me a history of what happened in the last few times I ran this test suite. So I now want to keep working with this test suite. The easiest way to do that is to actually, let me just get rid of everything here, is to say, okay, I'm going to rename test suite lfg.new to my test suite7.lfg. This is my new one now. Okay, and I'm going to work with this one now. Right, so everything's working. Now let's go for implementing comps. Okay, calling up grammar 7 again with the improved version. Make it a little bit bigger. With my new test suite that I just ran through to make sure that my grammar is growing and not just changing, so that I can still parse everything that I could parse before, and I can parse it well, not too many analyses, not too few. Okay, now the first sentence I'm going to try and do is Sophie said that tigers hate bananas. Right, okay. I shouldn't have to worry about names anymore. I shouldn't have to worry about any nouns anymore because we have the morphological analyzer. I do have to worry about said, and I do have to worry about that. We don't have these in the grammar yet. So let's do that. Let's think about what to do there. So let's start with an analysis for say. Let's go back to our analysis for eat. Okay, so we need verbs with clausal arguments. Okay, and we're going to have an entry for say. We're going to use the morphological analyzer. So we're going to call it a verb stem, XLE. And, well, now what are we going to say about this? I don't have a template yet. Let me just think about what we want to say. It has a predicate. The predicate will consist of a stem. We can write it like this. And what argument should it have? Well, it should have a subject, Sophie. And Sophie said something, right? So that will be said that. So that's a comp argument. So let's start with that. Okay. Is there something else we need? I can't think of something at the moment. Let's just start with this. So we have say, which takes a subject and a complement. We also need a complementizer somewhere. We should put that somewhere down here with the functional elements. So let's put down here complementizers. That, and this we're going to not have come out of the lexicon. It's a functional element. Those are usually good to just write by hand. So what are we going to call that? We're just going to say it has a comp form is equal to that, and we're not going to say anything else more. We're going to call it C. That's by convention for complementizer. It's a linguistic convention. Okay, so we've got lexical entries for our sentence. Sophie said that tigers hate bananas. Everything else should work. We should check that we have hate in there, but I think I did see it. Here's hate. That should be all right. So now let's figure out what the rule should be. Okay, so we have a root that can expand into a sentence or an imperative. That seems all right because Sophie said that the tigers hate bananas is a sentence. It's just a sentence that contains a that clause. So let me think about how to do that. So inside the sentence, we need to have a that clause. The sentence expands to noun phrase and verb phrase. That's also all right. Said that whatever is usually considered to be, the that clause is considered to be inside the verb phrase in English. So I need to go into my verb phrase, which is already quite complex and could probably be written better, and think about what to do. And if you know a little bit about English, you will realize that the that clause actually comes at the very end. So let's put in an optional that clause. We'll call it a CP, complementizer phrase, and we'll say this CP is going to be the comp of the matrix sentence. Ups comp is equal to down. We're going to make it optional because not all verbs have a CP. Okay. Then, of course, we need a rule for CP. That needs to be expanded. And the rule should be that, followed by a sentence, right? Because the that is followed by something that looks structurally exactly like a normal sentence. Tigers hate bananas. That should be parsable by just our normal sentence rule. And notice that we've built recursivity in here already because the S rule is being called up within the S rule. The S rule expands to NP-VP. VP expands to all these things, including optionally CP. The CP expands to complementizer and S. And then you can start the circle again. So we've got recursivity built in here. So that is good. Okay, let's try it. Let's see what happens. I can't think of anything else to add right now. Probably I've overlooked something. One usually has when one is implementing. But at this point, it doesn't hurt to try. So let's put our test suite at the bottom. I like to have it there. And try parsing. First, we have to create our parser. Create parser grammar 7.lfg. And I have some problems. One should always check this out. Okay, so what is my problem? It says, warning, possible missing full stop or quote near head word say. Okay, better go look at that. Looks like I forgot something there. And what did I forget there? Upspread is equal to that. The period is there, so what is its problem? Try that, whether it likes that better. Okay. Okay, so I had a wrong quote over here. I used the wrong kind of single quote. It got upset about that, so I fixed that. And now it seems to be loading quite nicely. So let's see if it can parse this yet, or if there's something else we need to do. And indeed, I can parse everything. I can parse that sentence at least. Let's see if it's the right result. There's 2 trees. Sophie said that tigers hate bananas. This looks good. Sophie is the noun phrase. Said is a verb. It's coming out of the morphological analyzer. Okay, it says there's past both, etc. That looks good. And it expands into a CP. This contains the that clause. That tigers hate bananas contains a VP. That looks good as well. Let's check the F structure. Does it look like what we had on the slides, or sort of? There's a main predicate say. Sophie is the subject. That looks good. It has a comp argument whose main predicate's hate. This is the comp. There's the main predicate, hate. Tigers hate bananas. Tigers subject, bananas object. That is also looking good. Okay. The only problem I see is that I actually have 2 trees for this. So there's another tree. What's the problem here? It's this one, the period is up here, and the other one, the period is down at the bottom. So that's not really good. That seems like an unnecessary ambiguity to introduce into a grammar. So let's try to do something about that. So where is that coming from? Okay, the period is down here once. And I'm expanding S twice. Remember, I'm going into S and expanding the period once here. And once again, I'm coming into it again through the CP. So there's 2 different ways of placing this period. Now that is not necessarily what we want. So what we probably want is we want to put it once up here, this period. So let's take it out here. Okay. And just say this. And put it up here instead and say, okay, whenever we have an S sentence, we want it to be followed by a period. And we add an OT mark because when we generate, we would like this period to be there for sure. When we parse, it can be there optionally. Okay, escape Q to make sure it's the right thing. Yep. Okay, so now it should only appear once. So let's reload our grammar. Create parser. No arrows, that's good. And try parsing the sentence again. And now we have exactly 1 tree and the period coming just at the very top here. So Sophie said that the tigers hate bananas. Okay, Sophie NP. Followed by a VP, the V is here, the main verb is here, embeds a CP, that is the complementizer, and then we have another S, that tigers hate bananas. The F structure is also good. Main predicate say, Sophie subject, complementizer argument, which has a pred, a subject, and an object in it, and the comp form that. So this seems exactly right. So that's successful already. So we did 1. So how about this one then? Sophie convinced the tiger to eat a banana. This will involve an X-comp, to eat a banana. So what do we need for this? We need an entry for convince. And we probably need an entry for to, and everything else should be all right. So let's try that. Okay, so we need an entry for convince. Convince. No, we don't have convince. So let's add one. Convince, verb stem, XLE, And what do we want to say about this? We want to say ups predicate is equal to the stem that we're getting from the other way, and subject. So what is our sentence? Sophie convinced somebody, right? Convinced the tiger. So we want an object. Ups object will be tiger to eat bananas, an ex-comp. Okay, and then remember from the slides, this is a control verb, so we need to say what the control equation is. So we say ups ex-comp subject is equal to, who's doing the eating in this case? Convince the tiger to eat a banana. It's the tiger, so it's an object control verb. Okay. So we have that information. Now we need an entry for 2. Actually, I would like to put it down here, but we're going to get an error. Anyway, I'll do it just to show you. So what I would like to do is say 2 is a special kind of, it's been argued to be certain different things. We're calling it an infinite particle, just to have some name for it. And we're just going to say ups v form is equal to infinite, or something like that in here. Okay, so I'm going to do that. Let's see what happens. I've only changed my lexicon so far. Oh no. We should keep on going. I know that's not going to work yet because we don't have any rules for this yet. So let's put them in. So we need some kind of VP with a to eat. And the easiest thing to do is to add a disjunction in here with a CP, because you can either have a CP or an infinitive VP. You can't have both at the same time. So either or this. So, and we'll call it a different type of VP. We'll say it's an infinitive VP, just to make things easier in terms of grammar engineering. And we'll say this one is the ex-comp of below. So either this or that. Okay, and now we need a semicolon here, clearly. And we need to expand that one as well. So a VP_inf will go to a part_inf. It needs to start with that, the 2-bit. If we look at it, 2 eat a banana. Okay, so now we've got 2. And then from there on, it's just a normal VP. So we can just say VP. Okay. From there on in, from after the 2, it just looks like a normal VP, and it has all the arguments, etc. that we have here. So we can just try to say this. Okay, so let's try that. This is the sentence we're trying. I need to reload my grammar. And I have an error. It says duplicate entry for head word 2. That means I've got 2 in 2 different places. So let me search for that. Of course, this is not going to be good. So this is the one I just added. Okay. So the grammar says there's another. Here's another one. The preposition to. And the way XLE works, I cannot have both of these just like this. So I either have to say something like etc. or I add it in here. Okay, and the best thing to do is to add it in here. Part_inf, and what did I want to say? Let me just copy that over and add it into the prepositions. Okay, so I want to have all that information, part_inf. Okay, so now I have 2, and it has 2 possibilities. It's either a preposition or it's an infinitive particle. Okay, so that should take care of that error. cannot have two head words. We'd have to do the XLE lookup model, do something with etc. We could have tried that as well, or we put it in one and the same entry. Okay, now let's try it again. Okay, now what do we have? We have some more errors. Let's see, what have I done wrong now? Missing morph code, syntax error at maybe near line 451. So let's go look there. Okay, so we've now put in the part inf. We fixed the to thing. We've got an expansion for the VP here. So let's try this again. We've restarted XLE. Let's do it again just to be sure. We load our grammar, create parser grammar 7.lfg. Okay, now I'm going to try and parse this again. Sophie said that Sophie convinced the tiger to eat a banana. And I'm not getting a tree. So let's look through this. Sophie seems okay. It's a noun. Convinced is a verb. That's fine. The is a determiner. So I'm just checking whether it can actually do all the verbs, all the words. Tiger, it's finding, it's a noun, good. To can be a preposition, we just changed that, and a part infinitive, that's good. It's also coming out of the morphology, but we're not using that. Eat is coming out of the morphology, it's a verb, that's good. A is a determiner, it's also coming out of the morphology, we're not using it, we're using our own version. Banana is also coming out of the morphology. And it finds the punctuation. So it figures out what all the words are. That's not the problem. The problem seems to be that we can't build a rule for it. But I told it to have VP infinitive here. But if I look at this rule closely, I started a disjunction, but I forgot to add in the or. So let's try it with this now. Reload the grammar. The wrong window, reload the grammar, create parser, get our buffer back with a test suite. Okay, now try again. Sophie convinced the tiger to eat a banana. Okay, we're getting a tree, that's an improvement, but we have a problem here. You see that there's a box around this VP. And I can say show F structures. Let's see if it tells me anything. And it says, I'm having a problem. I cannot find all my grammatical relations the way I need to. Eat with the subject is all right, but then there's this extra a banana, and I don't know what to do with it. And there's just always some incoherence going on. I can click through all these. There's 4 invalid trees. I could try them all. They come up. It says it on the VP. And here it says, the object is supposed to be third person or not third person. And this is now beginning to give me a clue, because before I wasn't really sure what was going on. But here this may be beginning to give me a clue. Let's try it again, the next one. So there's something going on with the agreement on the object, it seems like, that is not working. So let's think about that. So we've said that the subject of the XComp, tiger, should be equivalent to the object of the matrix. But if we look at this, we've got show morphemes. What's coming out of the morphology is this present tense thing. So what's happening is that the verb here is ultimately trying to agree with the tiger. And it's not necessarily being able to do that. Okay, so let's see. Let's see what happens when we say analyze string eat. Let's see what's coming out of the morphology. Okay, these are options from the morphology with eat. This is not necessarily what I would like, since I would actually like there to be a bare form that's compatible with an infinitive. But what the morphology gives us for eat is verb, present tense, and non-third singular. Okay, so that's what we have to work with. So let's look at what we've got there so far. So for present, what have we got? We have got this. We go to VP pres. Okay, fine. And what's the other information? Non-3 singular. There we go to bare agreement. Okay, so these are the two templates we have to look at. So let's look at vpres and bare agreement. Okay, and this says tense present, mood indicative. Well, we might not always want to do that. And what's bare agreement? This is where it's doing the agreement part. So let's start with this maybe and say, okay, we don't want it to do agreement if it's infinitive. Okay, so how are we going to do that? Well, here's one way. The morphology isn't telling us it's going to be infinitive, but in fact, we have the to, which tells us it is. So we could say, okay, if the V form, if we have information that the V form if it's not infinitive, then we want to do our normal agreement. Okay, so either we have a non-infinitive, then we can do all our agreement, or, another or, the V form is infinitive, and then we don't have any agreement. Okay. So, and then we can change the to one, the part inf. We can say that this needs to be infinitive. It wants some infinitive version. It's constraining. This is a constraining equation. This says it would like some value to be infinitive. So now this will require that the disjunction in bare agar will be triggered if there's a to around. Okay, let's try that. I actually personally hate agreement because it gets very tricky very quickly, even in English. But let's try it this way. Okay, so let's say when there's no infinitive, then we want this to happen. And if there is an infinitive, we don't need anything to happen. We don't need any agreement to happen. And then on top of that, we will make sure that the VP_inf is actually infinitive. We'll constrain that here too. We'll say ups V form, just to make sure, is equal to infinitive. Okay. There's an extra bracket here. Okay, let's try this again. Let's hope I got it right. If not, I'll have to check check my notes on how to do it right. But let's hope it's correct. So let me load my grammar. Okay, and I have some rule parsing error in the VP rule because I did something wrong here. There's this or that. So either that or, and then the whole thing is optional. There was an extra bracket there. Let's make sure that's correct. Now let's try again. I have a lot of students who don't read actually what XLE tells you here, so always make sure to read that. Okay, I fixed that. Now let's try it again. And now I'm actually getting a parse. Sophie convinced the tiger to eat a banana. The tree is good, and I'm only getting one tree. That's also good. Let's look at the F structure. Sophie, there's a main predicate convince, which has a subject Sophie, an object tiger, an ex-comp whose main predicate is eat. The subject of that is tiger, and this you can see here 22 is the same as the object of the matrix verb. And then there's an object of that, banana. Okay, now the only odd thing is here this tense aspect mood indicative, because it's not present tense in there. It doesn't have anything in there. So we could change vpres, our template, to reflect that. We could say again either ups vform, same as we did up there, is not equal to inf, and then we do our stuff. We call it present tense and indicative, or ups vform is constrained to be inf. Okay, so either we don't have it or we do have it. Won't bother with the constraining equation, we'll just declare that it has to be infinitive if it's not agreeing. Okay, now we can try it again. Okay, reload. No errors so far. Convince the tiger, and we didn't break anything, and we can check. Now in the ex-comp there's no more of this present tense mood indicative, so we fixed that. That's very good. Now let's check that this one still works, that we didn't break anything. That one still works, one valid tree. This still looks good. Always check that you don't break anything. And now let's try the next sentence. We have 3 more sentences to go. Sophie tried to eat a banana. Okay, let's do that one. Everything should be in place now, except for the fact that try is now a subject control verb, as opposed to convince. Okay, here's convince. I'm going to copy this entry to save me some typing. Sophie tried to eat the banana, subject control verb. First entry, I have to make it, here's try. Sophie tried to eat. It doesn't have an object. Sophie tried to eat, ex-comp, and the ex-comp subject is the up subject. It's a subject control verb. Sophie is the one who's eating things. Okay. Everything else should be in place, except for that lexical entry. Each should be around, we've got the VP, everything else should be working. We've only made a change to the lexicon, so let's just be bold and try it. Okay, and it actually works. Sophie tried to eat a banana, looks good. Sophie NP, VP try, embeds a infinitive VP with a infinitive particle in eat a banana. And then Sophie, let's look at the F structure. Try, main predicate, Sophie subject, eat ex-comp with eat as a main predicate, transitive, V-form infinitive. That looks very good. Okay, next sentence. That was easy. Now we've got try embedding convince. I should not have to do anything else. This should work because we've got the recursion already built into the grammar here, right? We can recurse The VP calls up the VP_inf, the VP_inf calls up a VP. So the recursion is already built in. It should work. Let's try it. Well, it gives us a parse. Let's see. Sophie tried to convince the tiger to eat a banana. A VP_inf embedding a VP, which embeds another VP_inf. Okay, that looks good. Let's look at the F structure. Try. Sophie is trying to convince somebody. That's the XComp. The XComp contains convince, which again contains another XComp here, which is eat. Again, this is what we want. This is very good. Okay, let's try another one. Let's try an XComp. Tried to convince. We already did that. And let's try to embed that. Try to embed a comp underneath that. Sophie tried to convince Jim to say that the tiger ate a banana. And again, without further ado, we've got this. Okay, we've got a VP_inf embedding a VP_inf embedding a CP, and that has a sentence in it. And here's the F structure for it. Sophie's subject has an XComp, which is convince. Convince takes a subject and an object and an XComp with say in it. Say takes a subject and a comp, and the comp is that the tigers eat bananas. So Sophie tried to convince Jim to say that the tiger ate a banana, all in here. And we should now be able to keep going and going and going. You can go home, and at home you can try this, and you should be able to have very long, very many embeddings without any further ado. So go out and try that. Okay. So this concludes, no, this is the wrong thing. We're not doing PowerPoint. So this concludes the demo part, the test suites and debugging and figuring out how to put in comp and XComp. So Grammar 7 will be available to you, as will be Test Suite 7. The practical work you should do is in exercise 8, where you will work some more with integrating verbal complements, write more control verbs, entries for control verbs, and learn about raising verbs as well. And so that is it for today.